Good morning, everyone. A very good morning to all of you, bacho. We are live. We are back on exam dos. We are back with the ESC Officer Series for Engineering Services PYQs. And I'm live here in front of you with a new subject, that is control system. So this is going to be our first session of control system. So everybody quickly join the session. Come on, everyone. Quickly join the session, everybody. चलिए, without wasting any time, let me start. Match list 1 with list 2. Physical action or activity and the category of the system. This is from ESE 2001. Match the two column. First is human respiration. It is a natural control system. Pointing an object with a finger. Natural control system. Man driving a car. It has both natural and man-made. Car is man-made, human is natural. Thermostatic controlled room heater, it is man-made. So 2231, A option. 2231. The mechanical system shown in the figure is described by. Now, beta, whenever you see such kind of problems which are based on mechanical system, you have to follow the nodal method of forming the equation. Okay? Nodal method से आपको equation form करनी पड़ेगी. Now, since it is a single mass system, I should be directly able to write. क्योंकि ये सिंगल मास सिस्टम है इसीलिए मुझे डायरेक्टली मैं लिख सकता हूं इसकी इक्वेशन. तो बेसिकली md²y2, देखो डिस्प्लेसमेंट ऑफ मास is basically y2. Correct? So this equation and this equation are wrong. Now the only difference between B and D is whether we should take y2 minus y1 or should I take y1 minus y2. Because this is appearing on the RHS, I will take y1 minus y2. देखो फंडा ये होता, displacement of mass is y2, so I will work at y2 node. I will work at y2 node. So when you take it to the right hand side, it will become k y1 minus y2. आप y2 node पे nodal लगा रहे, you are balancing all the forces at y2. That is why you are taking k y2 minus y1. Next, ESE 2002. Find the transfer function. Find the transfer function. This is simple. This is based on circuit. V0 by V1. Find the transfer function. So this is S. V0 by V1 I will calculate using potential division. S parallel 1. So answer will be C. Simple question. Answer will be C. For the multiple gear system, which of the following gives the equivalent inertia referred to shaft 1? Now remember, gear system acts as transformer. J is similar to inductance and B is similar to resistance. To refer J or B from one side to other, we follow transformer principle, that is multiplication by square of teeth ratio. Okay, by square of teeth ratio instead of turn ratio, teeth ratio. So when J3 will come here, it will become N3 by N4 square. Okay. Now when you take J2, and what about J3? J1 is already at shaft 1. So the total inertia will be J1 plus J2 N1 by N2 square plus J3 N1 N3 by N2 N4 square. इतना सब याद कैसे रखें? ऐसा रखता है पीछे का भूल जा रहे हैं. रिवीजन बेटा, एक ही तरीका है रिवीजन. Now, it is saying which of the following circuit correctly shows the force current analogy. Now remember, ये बेटा मैकेनिकल सिस्टम के क्वेश्चन है, मैथमेटिकल मॉडलिंग ऑफ मैकेनिकल सिस्टम. Now remember, whenever you want to draw the force current or the force voltage analogy, first of all you have to draw the nodal diagram. Now, how to draw the nodal diagram? So basically there are two displacements. So take two nodes, x1, x2. ठीक है, दिक्कत आ रही है. There are two displacements, that is x1, x2. Okay. Take one reference, that is ground. ध्यान से देखिए नोडल डायग्राम बनता कैसे है. ये टॉपिक आपका सवालों से ही तैयार हो जाएगा. This topic you can directly prepare from the question itself. So there are two displacement, therefore I am taking two nodes, x1 and x2. Now mass is always connected between the node and the ground. Always connect mass between node and the ground. Okay. Now there is a spring K1 between M1 and M2. There is a damper and a spring between M1 and M2. Okay. Then there is a damper ऑडियो आ रहा है बच्चों? यू आर एबल टू हेयर मी? So we were drawing this diagram. Force we are applying at M1. So force is always shown as a current source. Rest of the component I already drawn. Now in force current analogy, force will become current. Okay. Mass becomes capacitance. Spring becomes 1 by inductance. And damper becomes 1 by resistance. Okay, that is the analogy. So inductor, sorry, mass should be capacitor. This should be the case. ठीक है, ये बनना चाहिए. Is that clear? Mass will become capacitor, spring will be inductor, and damper will be resistor. This is ESC 2004. Next, maximum temperature rise, ESC 2005 is 50 degree. It attains 31.6 in 1 by 2 hour. What is time constant? 31.6 by 50 is 0.632. So beta system attains 63.2% of steady state value at t equal to tau. Therefore tau is 1 by 2 hour. Tau is 1 by 2 hour. Okay. Tau आपका 1 by 2 आ जाएगा. Is that clear? Next, transfer function of the diagram shown below, ESC 2008. Transfer function. Again, it is very simple. This is based on potential division. SCR by 1 plus SCR. B. Next, what is the function ESC 2008 plotted in the graph represents? Very easy. What does this function represent? Unit impulse. Here 1 is the area. 1 is the area of impulse. Okay. ESC 2009, a mechanical system is shown. It is set into motion by applying a impulse force. Assume system is initially at rest. Ignore friction. What is displacement? So beta, generally for a single mass, this is the equation. Now it is saying ignore friction. Now take Laplace. Laplace of delta t will be 1. S square plus k by m. So this is Fourier transform of sine root k by m t. C option. Okay, the answer is C. Clear? I have converted it to the Laplace transform of sine omega t. Next, free body diagram I need to show. I need to show free body diagram. कंट्रोल के लिए बेटा लैपलास आना चाहिए बस सौम्य. Free body diagram. Now, if this is a mass m1, this is a mass m2, there is no friction between the wheel and the ground. No friction between mass and ground. Okay, so m1 y1 is the displacement. The force is to the right. If I stand here, देखो m1 पे इक्वेशन क्या बननी चाहिए? ओके, this should be the equation. Okay, now बेटा if you take this to the right hand side, अगर आप इसको RHS में ले जाओगे, it will be y2 minus y1. So it should be y2 minus y1. तो अगर आप इन्हें अपोजिटली शो करोगे, देखो या तो सारे ऐड करो तो y1 माइनस y2 होगा. अगर ये तीन टर्म और ये दो टर्म अपोजिट हैं तो इट शुड बी y2 माइनस y1. इफ दीज थ्री टर्म्स आर ऑन वन साइड, these are on the other side, it should become y2 minus y1. Okay, so y1 minus y2 is wrong. It should be y2 minus y1. So A is the correct answer. समझे? So basically you can either draw the nodal diagram to write this equation, or just like nodal, remember, whenever you apply nodal analysis at any node, you subtract all the voltages from the voltage of that node. जब आप किसी नोड पे नोडल लगाते हो तो क्या लिखते हो? v1 माइनस v2, v1 माइनस v3, v1 माइनस 0. कभी आप v1 वाली नोड पे v2 माइनस v1 नहीं लिखते. You always subtract all voltages from V1 when you are standing at V1. तो यही तो कह रहा हूं, Y1 पे नोडल लगाओगे तो Y1 में से ही दूसरा सब्ट्रैक्ट होगा. तो ये सारे फोर्सेस ऐड हो रहे हैं, माने ऑल आर ऑन वन साइड. बट अगर आपको इक्वेट करने हैं तो LHS इक्वल टू RHS करना है, तो इसको RHS में ले जाओ. दिस विल बिकम y2 माइनस y1. So in this free body diagram, basically you are equating the forces on LHS and RHS, so it will be y2 minus y1. Next, ESE 2011 for the mechanical system with the mass and the viscous friction component x naught by xi. What is x naught by xi? So first of all, beta, let us draw okay, this is the type of the system. इसी तरह का सिस्टम है. I need x naught by xi. तो अगर नोडल से सोचोगे So you can say x naught plus नहीं, तरह से तो नहीं लिख पाएंगे सीधा नेटवर्क की तरह, क्योंकि मास में डिस्प्लेसमेंट होता है। करंट्स को बैलेंस तो करते हैं, इसका करंट तो यही आएगा। बात है m और b1 का क्या आएगा। B2S, चलो इसको ऐसे कर लो, ठीक है। कन्वर्ट दिस टू लैप्लास, फॉर मास इट विल बी s square m sb1। तो x naught by xi, now I can apply potential division। मास के साथ डबल डेरिवेटिव आता है ना, डबल डेरिवेटिव बिकम्स s स्क्वायर, ओके। तो b2 by 1s gets cancelled, so you can solve it like this। लॉजिक क्लियर हुआ मैंने क्या किया? जो टाइम डोमेन में डबल डेरिवेटिव आता उसे एस स्क्वायर कर दिया, सिंगल डेरिवेटिव को एस कर दिया। देन आई हैव यूज पोटेंशियल डिवाइडर। ESE 2001, sorry 2011। So this is force will be matched with voltage। So force voltage analogy, so mass becomes inductor, damper becomes resistor, spring becomes capacitor। So 4 3 1 2, D option 4 3 1 2। IIT BHU को रिटेन कर लो यार। ESE 2011, again a question based on gears। Theta 1 by theta 2 is N2 by N1, this is correct। Theta follows inverse ratio of teeth। जैसे ट्रांसफॉर्मर में करंट होता है ना, जस्ट लाइक इन अ ट्रांसफॉर्मर करंट फॉलोज इनवर्स रेशियो ऑफ टर्न्स, थीटा फॉलोज इनवर्स रेशियो ऑफ टीथ। नाउ T2 T1 all are correct। So 1 2 and 3। देखो this is T1, so when you refer T1 here, torque acts as voltage, torque acts as voltage। So T2 is T1 N2 by N1। This will be balanced by inertia and damping, ठीक है। और else refer inertia and damping to N1। When we refer inertia and damping to one side, we use square of the turn ratio। So torque acts as voltage in transformer। टॉर्क को रेफर करते हैं वोल्टेज की तरह यूजिंग टर्न रेशियो। इनर्शिया एंड डैम्पिंग को रेफर करते हैं एज इंपीडेंस यूजिंग स्क्वायर ऑफ टर्न रेशियो। ESE 2012, the law in mechanical system analogous to KCL is D'Alembert principle, that is sum of net force is equal to 0. जैसे sum of current 0 होता है, तो this is based on force balancing in free body diagram. So this is analogous to KCL. Okay. Next, again you have to match the column. So this is based on force voltage analogy. How can I tell that? Because charge is given. In force current analogy we use flux instead of charge. बेटा ये सब्जेक्ट तो इसी वाले बच्चे भी फॉलो कर सकते हैं. तो डिस्प्लेसमेंट इज चार्ज, मास इज इंडक्टर, डैम्पर रेजिस्टर, स्प्रिंग इज कैपेसिटर. So 2, 1, 3, 4. D option. 2, 1, 3, 4. While deriving ESE 2013, while deriving transfer function of a linear element, while deriving transfer function of a linear element, जब ट्रांसफर फंक्शन निकालते हो तो किन assumptions पे निकालते हो? इनिशियल कंडीशन 0 एंड नो लोडिंग इफेक्ट. इनिशियल कंडीशन भी 0 लेके चलते हो, लोडिंग इफेक्ट नहीं लेते. मींस कास्केड में डायरेक्टली यू कैन मल्टीप्लाई ट्रांसफर फंक्शन. इन कास्केड यू कैन डायरेक्टली मल्टीप्लाई ट्रांसफर फंक्शन. Now ESE 2013 open loop transfer function is given. What are the poles of closed loop transfer function? Where are the poles of closed loop transfer function? For unity feedback, numerator by denominator plus numerator. B square minus 4AC. तो आंसर इज सी. कोर्स चेंज के लिए क्या प्रोसेस है, मतलब कौन सा कोर्स चेंज करना है? ESE 2013, a transfer function has a 0 in the right half plane, so it is non-minimum phase. Non-minimum phase means at least one pole or 0 lies in RHP. ठीक है, कम से कम एक पोल या 0 RHP में चला जाए. वेरी गुड रोहन. Transfer function of this network. Now listen to me very carefully. This is very important. This system cannot be directly solved by cascading. Why? Because if you think like this, this is one network and this is your other network. If you think like this, cascading, but rule of cascade can't be applied because current flows from network 1 to network 2. This is network 1, network 2. This is basically loading effect. गेट से AJ अभी मंडे को लिया, तो बेटा व्हाट्सएप नंबर पे मैसेज करो जो पॉसिबल होगा. वैसे तो देखो कोर्स चेंज की तो ऐसा कोई पॉलिसी है नहीं, बट जो भी आपकी हेल्प हो पाएगी कोशिश करेंगे. So now, how to do this? Suppose you assume voltage V here. Now apply nodal. V minus theta 1 by R. V by 1 upon SC. V by. These two are in series because there is no current here. Theta 1 by R. Now theta naught can be derived from V using voltage division. Theta 1 1 plus SCR. This term is basically so this will get cancelled. Theta naught by theta 1. Okay. So answer is B. T is RC. टाइम कांस्टेंट इज RC. तो बस वही है कि RC की जगह T यूज कर लिया है. चलिए नेक्स्ट ESC 2014. सर्वो मोटर हैव स्मॉल डायमीटर एंड लार्ज एक्सियल लेंथ. ओके, सर्वो मोटर हैव स्मॉल डायमीटर एंड लार्ज एक्सियल लेंथ so that they have low inertia and high starting torque. करेक्ट. ठीक है, इसको स्पेशल मशीन में डाल लो, कंट्रोल में डाल लो, कहीं भी फिट कर सकते हो क्वेश्चन को. सर्वो मोटर का डायमीटर कम रहेगा क्योंकि इनर्शिया कम रखना है और एक्सियल लेंथ ज्यादा होती है शाफ्ट की. द ट्रांसफर फंक्शन ऑफ अ लो पास RC नेटवर्क इज. लो पास RC नेटवर्क इज B. 1 by 1 plus ST. What about high pass? It is like this. S by 1 plus ST. ESC 2015. The transfer function. V naught by V1. One by 1 plus SCR. ESC 2015. Servo motor differs from standard motor principally in its low inertia and high starting torque. It has low inertia and high starting torque. Desirable feature of a servo motor is low inertia, low friction. ठीक है, low inertia, low friction. Next, in the system shown ESC 22, the numerical value of M, B, K are given as M is 1, B is 2, K is 100. The mass is displaced 0.05 meter and released without initial velocity. What is the frequency observed in the vibration if the displacement is measured from equilibrium position? तो देखिए यार, now understand it carefully. There is no force. There is no force. But initial value of x is 0.05. Initial value of derivative of x, that is velocity is 0 without initial velocity. Initial velocity कुछ नहीं है. Now beta, when you take Laplace s square xs minus s x0 minus dx by dt, then b s xs minus x0 plus k xs. समझे, इसीलिए इनिशियल वैल्यू दी. m is 1, b is what, b is 2, k is what, k is 100. Frequency it is asking. So the damped frequency just less than 10 it will be 9.95. समझ में आया इस क्वेश्चन का लॉजिक? अच्छा क्वेश्चन है. दिस इज अ वेरी गुड क्वेश्चन एक्चुअली. बेटा दिस इज कंसीडर्ड अंडर मैथमेटिकल मॉडलिंग. और एक बार अपने सिलेबस में देखो मैथमेटिकल मॉडलिंग लिखा है क्या. ESE 2023, a negative feedback system has a forward path gain of 18, feedback gain of 0.15, overall gain. So if I go by analog definition, one point eight, 2.7, 18 by 3.7. 18 into 15, 270, 2.7, 3.7. तो 4.5 के ऊपर आना चाहिए A. Answer will be A. ESE 24, transfer function corresponding to following differential equation. S cube plus 4s square plus 6s plus 3 cs. When you consider transfer function beta, then while taking Laplace, ignore the initial condition. So s square plus 6s plus 4 by s cube plus 4s square plus 6s plus 3. Okay. ESE 24, transfer function of the given circuit. So VC by V, use potential division. Take LC common. A. IIT Bhubaneswar is better than IIT Patna. Consider the following block diagram. We need the function G1 by 1 minus G1 G2. बताइए कौन कौन सा आएगा. This will be G1 by 1 plus G1 G2. No. This is positive feedback. So G1 by 1 minus G1 G2. Right. Then No, this is right. Because of positive feedback. So answer is 2 and 4. This is ESE 2001. Very good, Rohan. Then, in the feedback system, CS, RS, DS are system output input disturbance. For system, CS into RS plus DS by RS DS. ये क्या कर रहा है? देखें कहना क्या चाहता है ये. तो C is D plus GR by 1 plus GH. मेरे हिसाब से तो डी होना चाहिए. सेकंड बात तो सही कह रहा है बेटा कि ट्रांसफर फंक्शन निकालते समय आप बाकी के इनपुट्स को जीरो करके निकालते हो. यू कीप अदर इनपुट्स एज जीरो, यू टेक ओनली वन आउटपुट एंड वन इनपुट. तो जैसे इसमें डीएस को जीरो कर दें. इसका यार कुछ लॉजिक ही नहीं बन रहा. ठीक है, चलिए. ESE 2002, which are the characteristic of a closed loop system? इनमें से क्या चीज आप क्लोज लूप सिस्टम के बारे में कह सकते हैं? What can you say about a closed loop type of a system? Okay, tell me. What can you say about a closed loop system? It does not compensate for disturbance? No. Disturbance reduced by it reduces sensitivity. Yes. It does not involve output measurement. No. Output is feedback. आउटपुट को मेजर करके फीडबैक किया जाता है. कंट्रोल ट्रांजिएंट रिस्पॉन्स. यस. तो बी. 2 and 4. इट कैन कंट्रोल ट्रांजिएंट रिस्पॉन्स. यस. तो बी आ जाएगा. ESE 2002, match the property with the specification. Relative stability. Okay, relative stability by resonance peak. Speed of response, rise time. Accuracy, velocity error coefficient. Sensitivity, return difference. So 4, 1, 2, 3, C. Okay. ESE 2002, number of forward path and non-touching loop pair. Start counting forward path. A, D, F, L. Okay, one forward path. Then A, H, L. ठीक है, AHL. A, E, F, L. Non-touching pair. One loop is B. B and GF. बस एक ही आएगा, C आना चाहिए. There is only one non-touching pair, B and this loop, FG. B and FG. बेटा मेरे पास ऐसा कोई अब वो नहीं है एक्सेस किसी प्लेटफॉर्म का कि मैं रिक्वेस्ट एक्सेप्ट कर पाऊं, ऐसा कुछ भी मेरे पास एक्सेस है ही नहीं आशीष भाई. मैच लिस्ट 1 with list 2 and select the correct answer. Basically, which block diagrams are equivalent? So this is RG plus Y. This is G R plus Y. Okay. RG plus YG. So this is A. G R plus Y by G. GR plus Y. This is B. RG and this is R. So this is D. RG, RG. This is C. So A is 4, B is 3, C is 1, D is 2. 4, 3, 1, 2. B option. 4, 3, 1, 2. Okay. Gain I need to find CS by RS ESE 2003. I need to find the gain C by R. So first check beta forward path. One is G1, G2. The other is G3, G2. Now check the loops. G1, G2, H1, G3, G2, H1 and G4. Okay? And all loops are touching each other. There is no loop which is not touching each other. All touch each other. Okay? Forward paths also touch all loops. Therefore, delta 1 equal to delta 2 equal to 1 and delta is 1 minus loop gain. G1, G2 plus G2, G3, B. Okay, answer is B. ESE 2003, the gain of the block diagram CS by RS. CS by RS. So if you see the signal here, beta, this is CH2, this is CH1H2. Okay. So based on this, I can basically modify the block diagram just a minute बच्चों. So now beta, what I will do is I will break this connection from here. I will bring this wire from here. Okay. This I will name H1, H2. Okay. So this will be G2 by 1 minus G2, H2. Okay. Then cascade with G1. And then I will use feedback. Okay. G1, G2, 1 minus G2, H2. So answer should be C. C आ जाएगा. Okay. चलिए next. Which of the following is not caused by negative feedback? ESE 2003. Gain reduces. Gain into bandwidth is constant. So bandwidth increases. Distortion reduces. So this is wrong. Okay, so answer should be C. Very good. Signal flow graph is given. Consider the following set of equation for the nodes. Which equation are correct? Now, value of node variable is equal to sum of incoming branches. Okay. So like x2, a1 x1 plus a9 x3, x3 a2 x2 plus a8 x4, x4 a3 x3 plus a7 x4 plus a5 x2. ठीक है, a5 x2 यही आ रही है ना इनकमिंग तीन ब्रांचेस. तो x2 is a1 x1 plus a9 x3 correct. x3 is a2 x2 plus a8 x4 correct. x4 is a3 x3 plus a5 x2 plus a7 x4 भी होगा. x5 a6 x2 plus a4 x4. ये जो सेल्फ लूप है ना इसकी वजह से भी आएगा a7 x4 a6 x2 प्लस a4 x4. तो 1 2 का 4 डी. नेक्स्ट कंसीडर द फॉलोइंग ब्लॉक डायग्राम. विच ऑफ द फॉलोइंग इज करेक्ट स्टेटमेंट. इसमें बताना है कौन से ब्लॉक डायग्राम सेम है. मैग्नेटिक फील्ड स्ट्रेंथ और रिलक्टेंस में जो लेंथ यूज करते हैं वो सेम होती है डिफरेंट नहीं. सेम मीनिंग होता है. ट्राई करें. पॉजिटिव नेगेटिव फीडबैक नहीं है तो नेगेटिव मान के कर लो। अब देखें भाई, वन बाय SC2R2, तो न्यूमरेटर बाय न्यूमरेटर प्लस डिनोमिनेटर। And then beta, if you shift this point, this takeoff point to the right, you will keep R2C2S plus 1. So earlier this was like this. Now you have shifted here. Okay. So A and B equivalent. Now if you take this 1 by R1 R2 C S plus R1. So this branch is 1 by R1 R2 C2S plus R1. Then a feedback of R2. Numerator by R2. So this is also same. So all three are same. All three are equivalent. Okay, all three are equivalent. Next, consider the following three cases of block diagram algebra A, B, C. Which relations are correct? ESE 2004. Sir, I have secured CET and NIT Jalandhar MTech VLSI self-sponsored. I want to try in better institute without losing too much money. मतलब यार अगर सीट सिक्योर की हो सेल्फ स्पॉन्सर्ड में तो सीट तो छोड़नी पड़ेगी ना, अगर आपको बाकी इंस्टीट्यूट में ट्राई करना है। बाकी CCMT में रिटेन करने का तो रिटेन करके बाकी आगे ट्राई करो। ओके, नाउ दिस इज x g1 minus y into g2 so this is x g1 g2 minus y g1, so not same. Okay, xg minus y just a minute. Same. This is gx minus gy. This is also gx minus gy. So block diagram B and C are correct. B and C are correct. Next, overall transfer function. Overall transfer function. I think this should be like this. Okay, ऐसा होना चाहिए. Now, this is a forward path. G1, G2. This is again a forward path. G3, G2. Okay. and this is basically a loop minus G2H1. So answer should be A. आंसर शुड बी ए. दो फॉरवर्ड पाथ हैं, एक लूप है. वेरी गुड रोहन. नेक्स्ट, मैच द लिस्ट वन विद लिस्ट टू ओरिजिनल डायग्राम विद द इक्विवेलेंट डायग्राम. ओरिजिनल डायग्राम विद इक्विवेलेंट डायग्राम. So here G x1 plus minus x2. Okay. Gx1, 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 okay. So A is matched to 3. Okay. So C is matched to 4. D is matched to 2 and B is matched to 1. 3, 1, 2, 3, 1, 4, 2. 3, 1, 4, 2. Okay, 3, 1, 4, 2. ESE 2005. ESE 2005. Signal flow graph can be used for block diagram reduction. Yes. Signal flow graph is a graphical representation. Absolutely correct. ब्लॉक डायग्राम का ही ग्राफिकल रिप्रेजेंटेशन होता है सिग्नल फ्लो ग्राफ. Therefore, you can use signal flow graph for block diagram reduction. Next, consider following statement regarding bandwidth. In system where the low frequency magnitude is 0 dB on Bode diagram, the bandwidth is measured at -3 dB. जहां इनिशियल स्लोप आपका या इनिशियल वैल्यू 0 dB है, तो बैंडविड्थ -3 dB पे देखोगे. करेक्ट, बिकॉज वी सी द बैंडविड्थ वेयर गेन बिकम्स 3 dB लेस देन द इनिशियल वैल्यू. Bandwidth is the measurement of the range of fidelity of the response of the system. What is the meaning of fidelity? Fidelity means where the system output is linear with respect to input और output varies directly with input. तो fidelity, जैसे हाई-फाई स्पीकर होते हैं तो उनका ऑडियो आउटपुट बहुत अच्छा होता है, बहुत शार्प होता है. तो bandwidth basically tells you the range of the frequency where gain is constant. So bandwidth basically tells you the range of frequency over which there is no distortion. Bandwidth आपको वो रेंज बताता है जिस पे डिस्टॉर्शन ना आए. तो बेसिकली इन अ वे इट इज टेलिंग अबाउट द फिडेलिटी. Speed of a response is proportional to bandwidth? No. Rise time is inversely proportional to bandwidth. So speed will be directly proportional to bandwidth. सही कह रहा है. Bandwidth बढ़ेगी तो rise time कम होगा, speed will increase. System with larger bandwidth provides slower response. No, it is faster response. Bandwidth बढ़ेगी तो speed बढ़ेगी, so it is faster response. Consider the following statement in connection with the feedback. With increase in forward gain, output value approaches the input in case of negative feedback. So as gain increases, error reduces. So this statement is correct. A negative feedback closed loop system subjected to an input of 5 forward gain 1, feedback gain 1 gives output. So gain is so V naught will be 2.5. So this is wrong. Transfer function is dependent only on the internal structure and is independent of the input. Correct. ट्रांसफर फंक्शन सिस्टम के कंस्ट्रक्शन पे डिपेंड करता है, ना कि इनपुट पे. ओवरऑल गेन ऑफ द ब्लॉक डायग्राम शोन इज 10. नो. 6 into 3 into 1, it is 18. So this is also wrong. 1 and 3. 1 and 3. Okay. Next, 46. ESE 2006. For a feedback system shown in the figure, what is the relation C by R? बेटा बैचेस के बारे में और प्रिपरेशन स्ट्रैटेजी तो देखो मैंने रिसेंटली लिया ही था, इलेक्ट्रिकल इलेक्ट्रॉनिक्स दोनों के लिए अरुण भाई. रिसेंटली मैंने प्रिपरेशन स्ट्रैटेजी लिया है, मैं आपको लिंक दे दे रहा हूं, और बाकी न्यू बैच का इंफॉर्मेशन मैं मंडे को दूंगा. ठीक है, अबाउट न्यू बैचेस आई विल इन्फॉर्म ऑन मंडे. जस्ट लेट मी शेयर द स्ट्रैटेजी. So I took it 1 month back. This is the strategy, Arun bhai. Now, if we see forward path is only 1 G, but loops are 2 minus GH and GF. So A. Answer is A. Okay. Signal flow graph has M number of forward path, P number of loop. ESE 2006. So let's count the forward path. A, B, C, D, E, F. A, B, H, G, E, F. A, B, C, G, E, F. A, B, H, D, E, F. ये 2 लाइन का एरो मिसिंग है यार. चलो ऐसे ले लो. Then A, B, C, H, G, E, F. And A, B, C, D, G, E, F. So 6. What about loops? C, D, H, G. Then C, G, H, D, C. ये वाला. Figure of 8. M is 6, B is 3. ठीक है, M 6 है और P 3 आएगा. चलिए नेक्स्ट. द ब्लॉक डायग्राम फॉर अ पर्टिकुलर कंट्रोल सिस्टम is shown. What is CS by RS? What is CS by RS? ESE 2007 it is. So one path is direct. That is 1. The other path is like this. So basically A by S. What about the loop beta? The loop is this minus B by S. So there are two forward paths. They both are touching the loop. So into 1. ठीक है? Both forward path touch the loop. Therefore, delta 1 is equal to delta 2 is equal to 1. Next, ys by xs. Ys by xs for the block diagram shown. What is y by x? G2 by 1 minus G2 H1. Okay. Then this is the feedback. Okay, this is feedback. This is cascade. G1 G2 by 1 minus G2 H1 plus G1 G2 H2. A. Answer is A. Next, ESE 2007 for a prototype second order system, the larger the bandwidth, the faster the system will respond. Bandwidth increases, rise time decreases, speed increases. Bandwidth and rise time are inversely proportional. Yes, absolutely correct reason. Which of the following block diagram is equivalent to the block diagram shown? RG minus C. So this is correct. B. The answer will be B. The below shown feedback control system has to be reduced to an equivalent unity feedback system. What is equivalent? Unity feedback system आपको बनाना है, क्या आएगा बताइए? Very simple. This is a standard feedback system. I need to convert it to a unity feedback system. The answer is D. Because it is 1 by H. GH by 1 plus GH. GH by 1 plus GH. So answer is D. For what value of K are the two block diagram as shown below equivalent? K के किस वैल्यू के लिए दोनों ब्लॉक डायग्राम इक्विवेलेंट हैं? So this is K by S plus 1. तो बेटा यूनिटी फीड K by S plus 1 plus 1. This is parallel, not feedback. So K is basically 1. K is 1. ESE 2010. ESE 2010 beta. Consider the following statement with regards to the connection. Feedback can improve stability or it can be harmful to the stability. Yes, feedback systems can be more stable or less stable. ऐसा कभी मत सोचना कि फीडबैक लगाने से स्टेबिलिटी बढ़ती ही है. It can even reduce the stability. Feedback can always improve stability. No. In many situations, feedback can reduce the effect of noise and disturbance. Yes. Feedback reduces the effect of noise and disturbance. And in general, sensitivity of a gain of a feedback system to a parameter variation डिपेंड्स ऑन वेयर द पैरामीटर इज लोकेटेड। इस बात का क्या मतलब है? देखिए, सेंसिटिविटी विद रेस्पेक्ट टू फॉरवर्ड पाथ इज दिस, sensitivity with respect to feedback is -1. So what is the sensitivity will depend whether the parameter is in forward path or feedback. सेंसिटिविटी फॉरवर्ड के रिस्पेक्ट में निकाल रहे हो या फीडबैक के, इस अनुसार सेंसिटिविटी वेरी करेगा। ESE 2011, the system transfer function for the block diagram, the transfer function for the block diagram. वैसे इसको डायरेक्टली भी कर सकते हो। दिस इज द फॉरवर्ड पाथ G1 G2 लूप G2 H2 लूप माइनस G1 H1। फॉरवर्ड पाथ touches both loops, so gain is G1 G2 A. Okay, ESE 2011, the transfer function C by R. Transfer function C by R. 54B not C. जब 134 आ रहा है ना, 54B C by R. तो बेटा फॉरवर्ड पाथ इज G and forward path is also H2. Loop is minus GH1. Okay. And both forward path touch the loop. So G plus H2 divided by 1 plus GH1. Next beta, next ESE 2011. Quickly we will solve. There is only one forward path G1 G2. These are two parallel paths in feedback. So you can say G1 G2. Simple. We will use the concept of a feedback system. Okay. ये तो सिंपल एक फीडबैक सिस्टम बन गया। If you combine both the path in the feedback, this is simple feedback system. Consider the following statement, ESE 2011 with respect to the signal flow graph. अब ये 5 और 3 का डायरेक्शन पता होना चाहिए। टू 7 10 40 ओके। तो लूप 5 into 4 into -2 2 into 4 into minus 2, 3 into 4 into minus 2. Okay, there are 3 loops. And gain forward path are 3. So 1, 4, 1, 3, 4. B option. 1, 3, 4. B option. 3 forward path, 3 loops, and the gain is 40 by 81. ESE 2012. Sensitivity with respect to forward path. This I have told multiple times in this video. With respect to forward path is 1 by 1 plus GH. ESE 2012. By using the feedback, the sensitivity to parameter variation is improved. This is achieved at the cost of loss of system gain. The gain becomes G by 1 plus GH. तो भले ही सेंसिटिविटी बेहतर हो गई बट गेन कम हो गया. Gain reduces. Now, ESE 2012 open loop transfer function is given. The closed loop will have a pole at. This is repeated. ये हम कर चुके हैं already. This we have already done. Next, ESE 2013. Which are the advantages of the closed loop negative feedback system? Reliability is more because error decreases. Transient response decays faster. Yes. Time constant decreases. Or you can say speed increases. Closing of the loop increases the overall gain? No. Gain decreases. Effect of variation? Correct. Sensitivity decreases. पैरामीटर वेरिएशन का इम्पैक्ट कम आता है तो आंसर शुड बी सी. 1, 2 का 4. ESE 2013. Excessive bandwidth is not employed because. Why do you not use high bandwidth in a control system? Because noise is proportional to bandwidth. High bandwidth means high frequency can be passed. Noise is present at high frequency. तो भैया अगर हाई फ्रीक्वेंसी पास करोगे तो नॉइज भी आगे जाएगी. Always remember, mostly noise is present at high frequency. With negative feedback, stability and gain इंक्रीज डिक्रीज. अब जब ऐसा चूज करना ही पड़ रहा है, वैसे जरूरी नहीं है कि स्टेबिलिटी विल इंक्रीज. यू कैन नॉट से दैट स्टेबिलिटी विल डेफिनेटली इंक्रीज विद फीडबैक. इट्स नॉट नेसेसरी. बट व्हेन अ क्वेश्चन इज लाइक दिस, यू हैव नो चॉइस, देन चूज दैट द स्टेबिलिटी इंक्रीजेस. ट्रांसफर फंक्शन. So this is a cascade combination. This is cascade. G1 by 1 plus G1 H1, G2 by 1 plus G2 H2. So you multiply the two. Answer will be B. नहीं, B में ऊपर H1 H2 भी आ रहा है, D आएगा. Because H1 H2 will not come in the numerator. Next, self loop can exist in block diagram but not in signal flow graph. उल्टा है. Self loop can come in signal flow graph, not in block diagram. Both block diagram and signal flow graph are used for LTI system. Yes. Why? Because the concept of transfer function is only applicable to LTI. Because concept of transfer function and convolution exist only for LTI. In a closed loop control system, closed loop control system, control action is dependent on output due to feedback. करेक्ट ना? एरर सिग्नल फीडबैक से जनरेट होगा. कैरेक्टरिस्टिक पॉलिनोमियल कैन बी डिफाइंड एज denominator polynomial of closed loop transfer function. The denominator of closed loop transfer function is called characteristic polynomial. If you make it equal to 0, it is called characteristic equation. Open loop system is inaccurate and unreliable because of internal disturbance and lack of adequate calibration. Closed loop is inaccurate as it cannot account environmental or parametric changes and may become unstable. तो देखो ओपन लूप तो आपका अनरिलायबल है, यस, बट क्लोज लूप इज एक्यूरेट. So reason is statement 2 is false. So this is correct. Open loop inaccurate है because you do not know if your output is right or wrong. There is no feedback. Last question. Open loop transfer function for the characteristic equation to solve like this. Divide by the polynomial having the terms other than k. So this is open loop transfer function because characteristic equation is like this. So GSHS will be this function. So what you have to do, separate the terms containing k and divide by rest of the terms. So that's it, beta. Tomorrow again we'll be meeting for control system at 11:30. Tomorrow at 11:30 we will meet for control system. Thank you.